Hello students, so this is Sukanya Mohri, lecturer electrical, and during this lockdown period as we are not able to sit in the class and clear your doubts, so here I am with the topic AC breezes from the subject measurements. So today we will be discussing some important points on AC breezes. So AC breezes, definitely this implies that this will be supplied with a AC source, okay, and the bridge looks like this. And as it is an AC circuit, so the term impedance come into picture. Impedance, okay, impedance means the opposition to the flow of current, opposition to the flow of current in an AC circuit, okay, which is usually represented as Z is equal to R plus JX, where R is the resistance and X is reactance, okay. So X can be XL minus XC, okay, and if it is purely inductive, then X is equal to only XL, which is equal to 2 pi FL. If purely capacitive, then X is equal to only XC, that is in capacitive reactance, and which is represented by 1 by 2 pi FC, okay. So our main is how to represent impedance, that is in the form of R plus JX, and this comes into picture when both L and C present, okay. Now let's first discuss that what is the general condition for a balanced AC bridges, okay. So general condition, in order to find the general condition for a balanced AC bridge, you need to know two formats, okay. One is polar format and another is rectangular coordinate format, okay. So what is that polar format? Polar format is when Z is represented in the form of Z angle theta. It means it has a magnitude and also an angle. When Z is represented in the form of R plus JX, then it is called as rectangular format, okay. And here theta is tan inverse and Z is mod Z is equal to R square plus X square root over, okay, fine. So let's start with the polar format, and the main condition is you have to go for a balanced condition, okay. So let's have a balanced AC circuit. So condition for a balanced AC circuit. Balanced AC circuit, your condition is Definitely, since this is a bridge which is consisting of four types of impedance, so definitely Z will be having its polar coordinate as it will be having a magnitude and a phase angle. Similarly, Z2 will be having a magnitude and a phase angle, Z3 and Z4 also. So let's start. Let your circuit is this. So we can say Z1 can be represented as Z1 angle theta 1. Similarly, Z2 can be represented as Z2 angle theta 2, and it will be R1 plus JX1. This will be R2 plus JX2. Z3 will be Z3 angle theta 3. These are all magnitude, okay? Similarly, R3 plus JX3, and Z4 is Z4 magnitude angle theta 4, which can be represented as R4 plus JX4, okay? So in our case, in the here we have to find a balanced condition, okay? So in order to have a balanced condition, let's follow this. What will we do? That is given by when Z1 into Z4 is equal to Z2 into Z3, that is the opposite arms impedance is equal to the this two product of these two arms, okay? So Z1 into Z4 into equal to Z2 into Z3, fine. So let's write down in the polar as well as in the rectangular form. So let's use the polar format, okay? So polar format is Z1 theta 1 into Z4 theta 4 is equal to Z2 theta 2 into Z3 angle theta 3, okay? So how to solve this type of thing? When it is in polar format, when they are in product, it is written as Z1 into Z4 and the angles get added up, theta 1 plus theta 4. This is the property, okay? Similarly, when the polar format it comes, Z2 into Z3 angle will be added. Understood? So the balanced condition will give me what? The magnitudes should be equal and the angles should also be equal. So Z1 into Z4 should be equal to Z3, that is case of magnitude, and angles will be theta 1 plus theta 4 should be equal to theta 2 plus theta 3, okay? Fine. Next we come to rectangular format. So for this, what is the balanced condition? Z1, what was the representation of Z1 in rectangular format? This. So we will write, replace all those Z1 in the form of rectangular. So it can be written as R1 plus JX1 into R4 plus JX4, which is equal to R2 plus JX2 into R3 plus JX3, okay? Then we can multiply R1 into R4 Okay, then it will be R1 jx4, then it will be jx1 r4 plus j square x1 into x4. Okay, similarly this r2 into r3 plus j into r2 into x3 plus j x2 r3 plus j square x2 into x3. Okay, we know j square is equal to -1. Okay, so replace the j square in by -1. So it will come out r1 r4 plus r1 j r1 x4 plus j r4 x1 minus x1 into x4. Okay, similarly this side it will be r2 into r3 plus j r2 x3 plus j r3 x2 minus x2 into x3. Now separate out the, this is the with the term j, that is called as imaginary terms, and without j terms they are called as real terms. Okay, so we need to now separate the real term and the imaginary terms. Okay, this is the actual process of solving a polar format and a rectangular format. So what do we do after that? We have found out the balance condition in case of polar. Similarly here we also need to find out. So in this above case the balanced condition will be balanced condition for rectangular format will be the real part will be equal to real part and the imaginary part will be equal to the imaginary part. That is r1 into r4 minus x1 into x4 is equal to r2 into r3 minus x2 into x3, and r1 into x4, that is imaginary part. Okay, x1 into r4 is equal to x2 into r3 plus x3 into r2. Okay, so this is the condition we have to do, or this sort of calculation you have to do while using the AC bridges for measurement of, you can say, inductance or measurement of capacitance. So these AC bridges are of different types which have been utilized for measurement of inductance or measurement of capacitance. So we will study in the further video the topic Maxwell bridge, which has been utilized for the measurement of an unknown inductance in the bridge circuit. Okay.